Thank you all for coming here. This is our DataMesh Journey. I'm Carlos Saona-Vázquez, and we'll be talking about data architectures and microservices. So the goal of the talk basically is to share with you our experiences with data and microservices. If you are worried that in your microservice platform you have more dependencies that you would like, or if you are worried that you have too many data pipelines in your systems, or if you are considering adopting machine learning at scale and are wondering how can you push data to the machine learning systems, I think that this talk, I hope, is going to be interesting for you. I think that this is a problem space that is still very open and it's evolving very quickly. So if you have other experiences, if you have tried other ways, I would be super happy. Please feel free to contact me, and I will really like to know about it. So basically, the structure of the talk is as in the right side. I will start with a brief introduction of who we are and what our platform looks like, so you can have a better understanding of our context and why we took the decisions that we took. Then there's 3 parts. In the first part, I will talk about why we adopted microservices, what challenges that brought in terms of data, and how we went with domain events. In the second part, I will talk about the analytical world, BI, machine learning, and the problems that microservices created for that world. And I will also explain a bit what are data lakes and why we choose them. And then finally, I will talk about the data mesh, which is a new paradigm introduced 3 years ago. And I will explain in some detail how we implemented the paradigm. And I will finish with things that are now we are cooking now. So very quickly, context. eDreams, in case you don't know us, it's an online travel agency. We are the second largest in the world in flights. Some numbers. The most important thing for this talk is basically that we have, it's a functionally complex system. We have over 250 microservices in 35 different business domains. We have around a bit over 300 developers in over 50 teams in 4 different locations, Barcelona, Madrid, Porto, and Milan. We are very heavy on data usage. Something has happened. We're heavy on data usage. Last year we did 1,000 A/B tests, and every day we have many machine learning models in production. On a day we can get to almost 2,000 million machine learning predictions. So now I'm going to talk about how microservices actually allowed us to get to those numbers, and in which ways we share data between microservices. So at the beginning we had a monolith, and in terms of data, the monolith is great. It's perfect because you only have one schema. All the data that you have, it's there. It's very easy to find things. You can join everything that you want. If you wonder which table, which team is in charge of which table, you can just look at the code. The problem, at least for us, is that the monolith, doesn't matter how well designed it is inside, it becomes a bottleneck for your development capacity, because at some point it's useless to hire more developers to do more work because they're just waiting for a free slot in the release pipeline. In our case, we didn't get beyond a few releases per day, and a few means maybe 2 or 3. So how can you fix that? Well, you have to split the monolith. And here in this table, you can see more or less the evolution that we took. We moved from 20 to 150 to 300 developers. And we did that by splitting the monolith and adopting microservices. The important part about the microservice definition here is that allows you to release autonomously, which enables autonomous teams, which enables parallel development. So then it makes sense to hire more developers. We went from the monolith to then a monolith, semi-monolith with some services around it, and then to a full scale microservice platform. And you can see that there's a very nice metric for this, which is the number of releases you can do in a single day. We had 1, then we got with 10, but then there was actually a role some years ago, which was release manager. whose job was basically to make sure that all the releases that were going to happen today make sense and fit together. This no longer exists in our company. Now every team does releases whenever they want, and we get between 60 and 100 releases per day. This is very nice, but then in terms of data, creates new challenges, because now how can you share data between the microservices? Because at the end, the microservice paradigm is about isolating your internal state from the external world. So basically, there are two ways to do this, two paths. One is just, if you want data from another service, you ask for it, you query for it. It's one way. Another way is the reverse. The service that has the data can push the data to the outside, and the other services will get it somehow and use it. And now I'm going to go through some real use cases of the last 10 years that show these paths in several combinations to show what are the problems and advantages. And as you will see, an interesting thing is that what we think makes it one better or the other better is not a technical thing, but it's a matter of your team size, your organization. For smaller teams, the best solution is one. And for bigger organizations with many teams, the best solution is another. So let's start with the simplest case, which is the query. It doesn't get any simpler than this. You have two domains, two modules, two teams. You have a booking engine that creates bookings, and you have the landing pages, which is owned by the SEO team, which basically is in charge of creating those HTML pages that you will find if you Google search for flights from New York to Barcelona. To create those pages, the SEO team needs to know which are the most popular routes that we do. So the booking team just exposes an endpoint in their API that will tell the other service which are the most popular routes. This has good things and bad things. One very good thing is that the landing page module is completely isolated from the whole complexity of the booking data model, which can get really very complex. On the other side, there are other disadvantages. For instance, what does really popular mean? Or what does a route mean? Because these definitions actually come from the SEO world, but they are implemented in the booking engine world. So if the SEO team wants to experiment with new definitions to try new things and improve their system, they need to ask the other team to do it. This, with a small team, is very good, but with a huge organization where teams are focused on a mission and that's the only thing they do, it's very difficult to get other people to do favors for you. And also, from an operational point of view, this creates risk, because what happens if one day the SEO team decides that instead of doing a query once per week, they want to do it once per hour? What will happen? Maybe it will have no impact on the database or the booking engine, or maybe it will. It's a risk. Next story, it's sometimes you cannot really query because the system that you're querying is not able to give you the kind of query that you need. In this example, the customer service guys wanted to add a feature to allow the call agents in the call center to search bookings with free text, which is something super useful for a call agent, believe me. Of course, the booking engine had a transactional database, so this is not really feasible without a lot of effort. But if you can put an Elasticsearch in place, it becomes very easy. So what did we do? We created a new service, which is the booking indexer. And then the booking engine, instead of offering a query, what we do is that every time a booking changes in some way, it will push the data using this endpoint to the booking indexer. The booking indexer will store it in Elasticsearch, and then the customer service can do all the searches by text that they want. This has mostly advantages. The customer service module doesn't know anything about the mechanics of retrieving a booking. The booking indexer can use Elasticsearch. It's only coupled to the booking world by the booking data model, but also can expose a booking data model to the customer service module that the customer suited for the customer service, not the original one. The only problem here is that this pushing with an API means that if the indexer gets down, then booking updates will be lost. And this went very, very well. It was super successful. It was so successful, in fact, that many other teams from many other domains started asking for new queries for the booking indexer. And so then we get back to square one in the previous slide, because now you have operational risk. And in this case, this was so successful that actually we went through downtimes because of this, because people started using querying things, and Elasticsearch suffered in the process. Third example from 2016, a bit more advanced. Now, again, booking engine. This time we wanted to replace the data pipeline that we had to BI. So instead of using physical table replication, we wanted to do something a bit less coupled to the booking schema. So now we have Kafka. So by this time, instead of pushing with an API, the booking engine would just push the booking changes. And then the new module, booking reporter, will consume that data. This case is different from the others, because in this case, the data that you want is not in one system only. It's in multiple systems. So then booking reporter need only consume the booking updates, but then enrich that information with information from other modules. And it did that with queries by ID. This, from a technical point of view, works very, very well. There's a little risk because, again, you're querying by IDs, and these are queries onto the systems. But a query by ID is usually very efficient and it's low risk. The problem here was not technical, was organizational, because by this time, we have grew already a lot. And it was an organizational problem created by an architectural feature. I mean, the evolution of microservices meant that teams were super specialized in a small scope. So then prioritizing things outside of that scope becomes very difficult. In this case, any bug that happened in this pipeline in the sending of message to Kafka, diagnosing it was very difficult, and prioritizing it also was very difficult. So, learnings from all these examples. Basically, there's nothing wrong with asking data with a query, as long as that query is inside the mission of the service that is exposing the query. In our example with the booking indexer, the booking indexer was exposing the search for text as a query to the customer service teams. But this is perfect, because this was actually the only reason why the module existed. What was wrong was the other queries that it was exposing to other domains. So then when the data sharing is outside of the mission of the service, then it's better to push data out. Because otherwise you will not scale, and the producer is going to become a bottleneck. Another thing that we learned is that because you always have more consumers than producers, and that because producers grow indefinitely, it's better, if you can, to push all the burden of consuming things, all the cost, all the effort to consumers. And then it's important to remember that just because you're pushing data into Kafka doesn't mean that you're not coupled to your consumers, because eventually you will want to change the structure of the data you're sharing. You will want to change your schema. And when that happens, you will have to synchronize, because the consumers will need to upgrade at their pace, and you will have to decommission and maintain different versions. So it's better that you minimize the data that you share, no matter how you do it. So then, how can we model the data that we push out to minimize these things? We chose to use domain events. Domain events with a little twist. Basically, I'm sure you are aware, you're familiar with this. Domain events is things that happen, facts that happen within a given domain. It's not the same as messages in a queue, because messages can be commands as well. And the way we modeled them was, as everybody else, with some controversial changes. Of course, we name domain events using a verb in the past tense, because that makes it more difficult to use to model an event that is not really an event. For instance, booking confirmed. Then we impose that a domain event can only be published by one single microservice to help with accountability. We impose that all events have an explicit schema, and the publisher is in charge of enforcing that no event is published that does not fulfill the schema. To ease sharing of data, we impose that all domain events have a shared common set of data, like IDs, or the version, or the module that is publishing, or the timestamp of the occurrence when the event happened. When it happened, not when it was published. And then the most maybe controversial part is that we limit the data that is allowed to be in a domain event. The first limitation is that we don't allow to publish data that is not owned by the service that is publishing, first thing. The second thing is it's okay to reference data from other systems, but then you just use the ID. And then even from the data that you own, the data in the event has to be just the things related to the fact that is happening. For instance, if you're publishing a booking cancel event and you're the booking engine, you have all the data of the booking. You could publish the whole booking in the booking cancel event, but we are not allowing to do that. We only publish the ID of the booking and maybe, if you know it, the cause of the cancellation. But that's it. If you want to know the origin or destination of the booking, that happened in a different event because it happened in a different time. And in our experience, you will be tempted, if you try to do this, you will be tempted again and again to break these rules. Because with these rules, what you're making is the life of the consumer more difficult. Because if you want to know, you're consuming booking canceled, and you want to know which booking was canceled, you have to have been listening to the booking created event to know which route and which buyer, the contact person, all the details. But it's worth it that you resist this temptation, because remember that you're going to be coupled for a long time. And remember that data has this nasty property of usually outlasting the code that you write. The data will be there when your APIs no longer exists, probably in your company. So then a few implementation details of how we do this. We use Kafka as our streaming platform. We use Avro to serialize and to express the schemas of the main events. There are Maven plugins that will generate automatically the code to serialize and initialize the schema. You can document your fields, your records in the Avro schema definition. And to make easy to distribute and to consume events, what we do is that if a service wants to consume an event from a different service, it only needs to import an artifact in Nexus with a code that has the serialization and deserialization to consume the event. For this, what we do is that for every service that publishes domain events, we have a separate Git repository that contains the schema. And when you build this repository, what it generates is it's the artifact with the schema and the code to read and write the events. And last, to ensure that we have a standard data on all the events, we have a shared library that basically isolates you from the details of the Kafka publication. It also sets the standard data like the IDs and the version and timestamp. And as an extra benefit, Kafka guarantees delivery, but it's not transactional, in the sense that if you have a running transaction, you cannot really link the transaction to the event. So maybe the transaction rolls back, but you have already published the event, or it has committed, but by that time your system goes down and you didn't have time to publish the event. So this is easily, this can be solved easily. You just, when you want to publish the event, instead of sending it to Kafka, you need to just insert it in a table within the transaction that you're running, and the library will do this for you. So going back to the first example of landing pages and bookings, how would this look if you use domain events to share the information? Well, Booking Engine publishes many events about the life of bookings, but for the landing pages example, the only thing that really they need is the booking created to get the route, the origin and destination of the booking, and the booking confirmed, because they only want to count the bookings that actually ended successfully, that got paid, and the airline confirmed. So everything is good here because Booking Engine knows absolutely anything about the SEO world. Landing pages team has to work a little bit more than before because now they have to consume 2 events and join them on their own. But then they're free to experiment any way they want with popularity or with the time window of the counters, or maybe with the routes, and they can now do cities and airports and cities with countries on whatever they want. And there are no operational risks involved also. So that's the first part, microservices and how we share data. The second part is about the analytical world, BI, machine learning, how microservices impact the data there, and data lakes. So data has a life beyond the microservice world, the platform. In fact, it has a longer life. And there are many teams that we can consider analytical. BI is a very clear example. Also, monitoring, in our case, to ensure a 24/7 availability is not enough to monitor technical KPIs like response time. That's not enough. You need also to monitor business KPIs. For instance, in our case, it's very important the ratio between searches and bookings. That tells us if the thing is working well. And every time, continuously, we will compute this ratio and compare it with the same ratio yesterday at the same time and last week at the same time. So monitoring team actually needs the analytical capacities because this data is not in one single domain, it's distributed across many domains. And also data science is an analytical team, and a very special one for that matter because they are the ones that are more greedy for data. All of these analytical teams had a much easier life with the monolith because now in with the microservices, what data do you have in the company? It's not an easy question because there are dozens of schemas in the cloud. And when you find the data, getting support from the team that owns that data, it's more difficult than before because, again, they are now way more specialized. They have their mission, and it's very difficult to get them out of the mission. Also, tricks like replicating schemas physically you have to forget about them because that couples you immensely to the team. You can't even rename a column without having to coordinate. You cannot join anything, for sure. And data is a bit less trustworthy because there are no integrity constraints across microservices and there are no transactions. Of course, life always finds a way. So what all the teams do is they create their own pipelines and their own data silos. They all create ways of pushing data out of the platform and putting them into their own systems, which works, it does, but then comes with its own set of problems because first, developers complain because they get very tired of supporting who knows how many data pipelines. Analytical teams also complain because they don't get all the support from the teams for the pipelines that they want, and because when there are bugs, it's difficult to fix them, and also because the data silos are inconsistent because the pipelines are different, which means that you come with a report, another team comes with a report. They don't really match completely, and that doesn't create an atmosphere of trust in your reports. And the most important part is data science is a game changer here because, as I said, if you start using data science, you want to use it in all your domains. So sooner or later, the data scientists are going to want a complete, consistent, cohesive data set. They want everything that's happening in the company. They don't want just a single piece. So we had this problem. And when a few years ago you looked, what can you do about it? The solution was the data lake. And conceptually, it's quite simple. It's instead of having data silos, you only have one repository. And to minimize the work of the pipelines, that repository has to have the data in its raw format, as close to the origin as possible, because that means that the pipelines don't have to transform the data. You do the transformation afterwards, which also means that the data in the lake has different formats. It's fine. The problem is that if you go to Wikipedia, you will see that there's this sentence talking about that data lakes that are poorly managed are called data swamps. And this is really disturbing that we have a name for data lakes that are not very useful, because I think this means that it's not trivial at all to build a data lake that is useful. And data swamps are basically, if you read about them, there's lots of people talking about them, is yes, we push the data there, but then nobody knows where it's coming from, and nobody knows if it's trustworthy or not, if it has errors or not, so it's basically useless. So this was very worrying, so we studied some literature, and then we went to big consultants that had lots of experience with data lakes, and what we understood was that to avoid the data swamp, you needed data governance, and you needed to have a central data team that was in charge of designing the schemas in your data lake, so data made sense, and also was in charge of all the ingestion of data from your systems to the lake to ensure that the data that got there had the quality that you want. But that created lots of doubts for us because in our minds, we couldn't really reconcile this management of data with the whole microservice story that I just told you about. Because how can you really have a central data team that can design the data model for a whole company when you have 35 domains and you have 300 people working every single day changing those domains? How is that team going to keep up with the rate of change in the data? And also, they are accountable for the data quality in the lake. How does this work really? Are they going to review all the releases every day to ensure that the data is not being corrupted? If you do this, then we're back to the release bottleneck with the monolith. But if you don't do this, and people can release whatever they want, then this team is going to what? Monitor this and then alert that there are problems. But this, we already knew about this with our BI and bookings. How are you going to prioritize these errors? So we didn't really know how to make this work. Which brings me to the data mesh. We were very lucky because when we were having doubts, there was an article in 2019 in Martin Fowler's website by Zhamak Dehghani proposing a new paradigm as an alternative to the data lake. And basically the paradigm has three ingredients. The first one is to use domain events. To share data between the microservices, but also because with domain events, you have a stream of domain events, so it's easy to get all the domain events and archive it, persist them somewhere in a central repository. Great. The second ingredient was to treat data as a product, meaning that data is not something that happens, it's just something that the teams need to treat as a first-class citizen. They need to feel accountable for the data that they produce. And also, they need to be the ones that decide which is the service level of the data that they're pushing. So which is the quality of the data that they're sharing with the rest. And the third ingredient was this self-serve platform design, which is basically that in order to minimize the complexity and multiplicity of your pipelines, make sure that you do them domain agnostic. So in the domain-driven world, this would be a generic service. If you do that, then you can have all your domains using the same pipeline. And we really love this for many reasons. First, it provided an approach to match data into a single repository. Then it was designed at the beginning, thinking about autonomous teams, structure around domains, and working autonomously with microservices. It unified the architecture that we wanted in the microservice platform with the architecture in the analytical platform. And very importantly, made data quality a function of the domain. In many companies, not all the domains have the same level of business maturity. You have, in our case, flights, hotels, which are very mature, and then you have lots of MVPs. The data quality needs are not the same in all these domains. And also, it showed us a path and approach to have efficient pipelines and not multiple pipelines. Of course, this is a paradigm. It's very abstract. So to actually implement it, you need to make some decisions about architecture, design, and implementation. These are a few of the decisions that we made to go with this. Of those three ingredients, the one that is more challenging and more difficult, I think, is the data as a product. It's very easy to say that teams need to treat data as first-class citizens and they need to be accountable for the data, but how do you really make that happen? So we use three principles here. First, we would favor governance by automation. So instead of manual controls, we would automate things to ensure that things happen in the way that we wanted. The second is that we would foster feedback loops. We think that the best way to ensure that teams push data with the quality that we want is by making sure that the same team is consuming that data for their own purpose and mission. And the third one was what I mentioned before. We wanted to favor shifting the burden of consumption to the consumers, because there are many more consumers and this scales better. The second thing is that also in our experience with these kind of systems, it was very difficult to budget the systems, not because of a lack of money per se, but because I own some data, I put the data so people can query it, I can forecast with a year advance how much my data is going to grow, so I can forecast how many storage I need, but how can I forecast how many servers I need? Because the whole company is making queries to this. Many people do not know enough to optimize the queries. How can I really budget this? So as a principle, because we were doing something new, we wanted that the financial cost was something that was pushed to the consumer. So the producer would take care of paying for the storage, but the consumption should be on the consumers. And last, in terms of rollout, how do you put this in place? The one approach was to let's put all the data in the mesh and then we'll start consuming. We didn't want to do that. Instead, we decided to go case by case. And by case, I mean a case of consumption. So we did not push any data set if there was not somebody asking to use it, first thing. This meant that we didn't do an upfront design of the whole data model of the mesh. Instead, what we do is we use each case to come up with design rules for the domain events and the data sets, case by case. Because we wanted that the aggregated thing afterwards fit. And this creating design rules to make sure that at the end everything fits is a bit maybe risky, but we also had experience with this. Because at the end, in the microservice world, with the APIs and the composition into microservices, how do you really ensure that all the pieces fit together? Probably you have a process. We also had a process. So what we did was to use the same process, only a bit tighter, only a bit more rigorous, because we thought that data is a bit harder than code. And third, we, from the day one, we published to the company that we had to accept that we will have a learning cost. This going case by case is very nice, but it means that the first cases are very slow because you're learning, you're creating the design rules, and also because after a few cases, maybe you realize that something was, you want to do it differently. So you have to go back and change it. So how does the architecture of the mesh look like in eDreams? Basically, you have the two worlds. You have the microservice world, and you have the analytical world. The microservices are exchanging domain events all the time. And there's one special service, which is this domain event mesh loader, that consumes all the domain events that are in Kafka and writes them to BigQuery. We have one table in BigQuery for each domain event. These tables are created automatically by the service. And also, the service pushes metadata into a data catalog, which is a nice UI that analysts can use to search for all the events that we have in the system, all the data sets. In the UI, you have all the documentation that is filled automatically using the documentation that is in the Avro schema. You have metadata like which is the team which is the module that publishes it, and from the module you can get the team. Also, why BigQuery? Well, first, it's a cloud-native data warehouse, so it means that you can query it. You can have data sets of terabytes of data, and it works quite well. It's designed so you don't have to really create indexes across tables. You just put the tables there, and it works. It supports standard SQL, which is very good for data analysts. It has Avro support, and it has this nice property that we wanted, which is that it separates the bill from storage to queries. So we can build consumers differently from producers. And also, it allows you to define access policies that are based on tags that you put on columns, not rows, and not tables only, which is a must-have to comply with privacy laws and with regulatory regulations from credit card companies. And of course, data engineers can use the data sets here to do their things, like, for instance, train their machine learning models. So the challenge with this is basically this magic service that creates tables and writes data there. How do you make it agnostic? How do you make domain agnostic? How do you make it generic? So basically what we did is that we created a new central repository where you have one YAML file for each domain event. And then teams, when they create events, they have their Avro schema in their own repository, but they also do a pull request with the YAML file corresponding to the domain event to this repository. And in this YAML file, you have information like the domain of the domain event, the service that is publishing it, and then, for instance, which fields have personal information or which fields have financial information. Also, configuration things for big tables, for BigQuery, sorry, like how you want to partition the data or how you want to cluster the data. And if you have this, then it's quite easy to have a service that can read this, can read the average schemas, and then can consume events, push them to create tables in BigQuery, and update the data catalog. Another example of automation in our implementation is data loss. In our experience also, a big problem we have with data, with the data pipelines is that from time to time you lose data. It happens. But the challenge was not to fix the bugs. The biggest challenge was actually to diagnose where the bug was, because there are only two options. Maybe it's in the pipeline, or maybe it's in the code of microservice. But to know which is difficult because the teams are different. So what we did is, well, BigQuery doesn't have foreign keys. But anyway, we have data sets where you have an ID, and there are other data sets that reference that ID. So one thing that you can do is you can scan both data sets, and you can look if all the foreign keys are actually primary keys in the original data set. And with this, you can have an estimation of the data loss in any given time frame in any data set. You need to do this generic domain agnostic, is to be able to configure for each data set where is the foreign key in which other data set. And if you do this, then you can have jobs in Dataflow, for instance, that continuously do these scans and then publish as a metric the data loss for each of these data sets. You can also alert people when this happens. And also, each time you scan, you can write this inside the same data mesh. So when a data analyst is doing work and is querying data from maybe 6 months ago, he can actually query this table to see if during that time frame there were significant data losses or not, or data losses beyond the threshold defined by the team, because each team that owns a data set is the one that defines the threshold of acceptable data loss. And also with this, became way easier to diagnose when there are data losses, whether it's coming from the pipeline or from the microservice. Another thing I mentioned that for us, feedback loops are the key to ensuring data quality. So what we did is that we created self-service capabilities to foster feedback data loops. As of now, we have 2 of them. One is, if you remember, we need business KPIs, and some of these business KPIs span multiple domains. For instance, the ratio between searches and bookings. So it's doable. You can create a generic system where teams can just do a pull request with a piece of with their SQL query, and the system will run this query periodically and output the result of the query to our alerting system, which is Datadog. It will define a metric in Datadog and will fill the data continuously. So then the team that defined this can go to Datadog and they can define their own alert based on this KPI. The other thing that we're fostering is that in Google Cloud you have a reporting tool, basic but powerful enough, which is Data Studio. So we are fostering that teams use this tool for their own reports and dashboards, connecting to the data mesh. So with this, I'm finishing. Things that we're working on now, we want to use Kafka Registry to enforce some policies regarding version control and ensure backwards and forwards compatibility. We also want to add a new pipeline, not for domain events, but for snapshots, because in some use cases, domain events add too much complexity to the consumer, because some kind of consumers don't want to know all the details of the life cycle of the entity. They just want the final state. For those cases, we want to work on having a generic snapshot system. Then we also want to work on integrating third-party data sources, because sometimes analysts want to join the data of our platform with data from providers. And we want to enrich the feedback loops and have more of them. And also for you, if you find this talk interesting, there's a book by the author of the DataMesh paradigm that was released just 2 months ago. And there's also a very good article by Ben Stopford about how to use domain events in microservices. And with this, I'm done. If you have any questions, I'll be happy to answer. Yes?
So I guess your events can evolve over time.
Yes.
Yes. So yeah, events can add new fields over time. How do you handle that? Because I saw you have the Apro contract on one hand, and then you also have your YAML representation. Yes. I guess there might be scenarios where some events just reach with a new model before the YAML has taken place into your centralized service, or you do it the other way around?
No, because For the YAML is a pull request, and the pull request is approved by the team that owns the pipeline. So this cannot happen out of sync.
Okay.
And for the schemas, this is what we're working now. I mean, at the end, what you want to do is to be able to publish the. First, you want to foster that people, when they make alterations, they make them compatible. Either backwards compatible, forwards compatible, depends on the case, or even both in both cases. There's some easy ways out of that. For instance, if your retention policies are very low. If you don't want the events to last for a long time, this is easy to manage because they get deleted after some time. But what we want to work is on the Kafka registry. So we want to enforce, to have default policies to ensure that when things change, they comply with the policies that we published.
Okay,
this is going to come. Now we match it manually, let's say.
Okay, cheers. Thank you.
Yes? What time is it? Yes, we're on time.
First of all, thank you for the presentation. Like it's one of the best like architecture sessions we had, at least from my point of view.
Thank you very much.
One question would be, so you mentioned partially like you're planning snapshots and things, but currently you are storing all the domain events.
Yes.
In the and like, is it like consumer friendly? Like, because it feels like then consumers have to understand the life cycle. If you have like booking created and confirmed and
yeah. This is a very good question. This actually was raised when we were creating the rules. How should you document your domain events? There's one approach, which is if I get a domain event, I read documentation, I need to understand everything. This is one approach. I think this is unmaintainable. So we went with something a bit more decaffeinated, if you want, which is if I know about the domain, I need to be able to understand the documentation of the domain event. So in general, also we have the data catalog. It's nice. It's simple but nice. If you're a data analyst, you can go there, you can search. This is Google. You can search by text, and you can find all the events with a certain word. And then you can see the documentation of the fields. And the important part is you can see the service that is publishing it, so you can go to the team and ask all the questions you want. Usually analysts are experts in some domains. And when they want to another domain, they understand that they need to study a little bit before. And as for coders, when coders want to use an event of another system, it's because they have a feature to implement, so they need to have that understanding to begin with. And actually, the domain event is a good place because it gives you like a script of the things that you need to ask. What does this mean exactly?
Okay. Thanks. I have time like for just a tiny one. You are storing events in a transaction with the other changes, right?
Some.
Yeah,
not
which
all of them.
mechanism do you use to publish them to Kafka? Is it polling or like CDC or something like that?
No, we're not using CDC. You're not using CDC. We thought about it, but CDC, it's coupled to the database. It's coupled to the representation, internal representation. It's useful for many things, but for this, if you want to work at the domain level, CDC is not good. So what we do is that the library has a method to publish. And then in the code, if you want to publish a domain event, you just have to do, you have to invoke the publish method. If you want transactionality, which is something that sometimes happens, then the library, what it does is it isolates you from that, because when you publish, instead of sending to Kafka, the library will insert into a table that enrolls in the same transaction, which ensures that you only publish the event if the transaction succeeds. Have I answered the question? You looked.
Yeah.
You don't look satisfied.
And I'm wondering, like, I guess you store event in a table in a transaction, and that's clear. But then from that point, it has to go to Kafka.
Well, yes.
Yeah.
The library has a separate thread, yes.
Okay.
That reads asynchronously, but only reads the committed rows, yes.
Yeah, that was the question.
And that ensures, yes.
Thank you. Thank you.
I thought.
Hello.
Hi.
Thank you for the presentation. It was really cool. Yeah, my name is Jared. I work at Celonis. based in Germany, in Salonis company. So yeah, maybe you mentioned already during the presentation, but maybe I missed that. So my question is, how do you decide which data goes along with the domain event, to be stored in the big query? So for example, in my understanding, event, it's just like some kind of event that something happened, but like service can have some data inside, and it can be like quite big, for example. And how do you decide which data, which subset of the data goes?
We have strict rules for that. The thing is that in the domain event, there can only be data that is generated by the service that is publishing it first. So if you publish a booking and the booking has a relation with another entity, you publish the ID of the other entity, but not any data of the other entity, first thing. Second thing is that even for the data that you own, the domain event, you don't publish anything that is not strictly related to the thing that has happened. And the example I gave in the presentation was the booking cancelled. If you have a booking cancelled domain event, in that booking cancelled, there will be the ID of the booking that is being cancelled and the reasons for the cancellation. But you will not have anything else of the booking. You will not have the buyer, you will not have the route of the booking, you will not have the airline, nothing there, because that's not part of the cancellation of the booking. And we do this on purpose because we want to minimize the coupling of each domain event to the service and to the consumers. It adds more work for the consumers, but as I said, we want to push as much as we can the work from the producers to the consumers. Does that?
Yep. Okay. Thank you very much.
This is, I think, controversial. I think part of the reason for doing this talk is to know if other people are doing different things.
Thank you for the presentation. And my name is Abu Bakr. I'm working for STC in KSA. Relate to his question. Okay, can I store this data because? For domain, we have transaction of around 600 call per day. Can I store this data? I just don't want to just event ID. I need just some more details.
Sorry, I don't think I understand the question.
Related to his question.
Yes.
Okay. You mentioned that you just store some of the transaction, like transaction ID. You don't need to go for the booking cancellation and all these details, right?
Yeah, for each domain event is a fact that happened. You store the data of the fact that happened. You don't store. You don't put in the payload of the event.
Okay.
The rest of the entity. Usually, the domain event is something that happened to an entity, to an aggregate. But the fact that happened only impacts a part of the data of the entity. So that's what is in the domain event. The rest is not there. If you want it, you have the ID of the entity and you can retrieve it yourself. If for any reason, for you it's important to know the state of the whole thing when it happened, then it's written, I then say it. One thing you can do is then you have to put versions in your entity. Okay. And then you can publish not only the ID of the entity, but the version. So you can retrieve afterwards, if somebody wants it, you can retrieve the whole snapshot. But we think it's better this way because context is more difficult than the final state. So it's better to give you context, and then it's easy to get the state afterwards if you're interested. And if you're not interested, then less coupled that you are. Yes?
Okay, thank you so much.
Thank you. I think we're running out of time, but I can stay. You can stay after this. Huh?
Hello, thank you for presentation. It's related to the last questions. For example, if you have a booking that is created after that several updates, how do you know how a consumer that needs to know all the data of that booking? No? How to know the state of that booking?
Well, I don't know if I understand. There's one thing about ordering, for instance. How do you consume the events in order? This depends on how you implement the event, the stream. In our case, we use Kafka, and Kafka guarantees the order as long as you use the ID of the entity as the partition key. If you do this, as we do, then you will always receive the events in the same order they were published. First thing. Another thing is, how can you retrieve the whole state? There's a difference between domain events and event sourcing. Event sourcing means that if you consume events, you always have the final picture of the thing. With domain events, that need not be the case. In our case, it's not usually the case. It could be the case if all the different transitions that you can have actually create a domain event. Then it's true. But for a surprise for us, and for me personally, was that we are covering, I don't know, 95% of all the use cases, and we don't really need a domain event for every single thing that happens. We don't. Just with a subset of the things that happen, it's enough, because at the end, your consumers in other domains are interested about little things. For instance, cancellation is very useful for the people that do customer support. They don't care about all the other complexities at all. It's true that in some use cases, people really want the state, and then the business logic that is conveyed with domain events, it's a complexity. So if I only want the state, you're not doing me a favor if you have all the domain events possible, because then I need to understand what they mean to compose them. For me, then it's easier just if you give me your final state and you publish the final state. And this is something that we want to do, but we're thinking it's still ways. It's easy to do case by case. We want to do something more generic for this.
Okay, thank you.
I think we're going to
Apache Kafka in your case looks like a single point of failure. How you tackle this? Are you scaling it somehow, and are you using Kubernetes for this? Because I know that many companies faces some problems with keeping
yes,
Kafka
it's true. If you use Kafka, you have a logical single point of failure, because you can have different clusters. In our case, yes, we have it in Kubernetes, and we are planning probably to go to a managed service with more replication.
Okay, thank you for the presentation and for the answer.
Thank you very much.
You said that normally users, consumers, don't need the full picture. Okay, there are some cases that the users need it.
Yes.
You have is a problem for you, or maybe you have developed some internal framework?
Yes, it's a problem because in those use cases we are not covering them. But in the feature slide, the thing we want to do is to, on top of the domain events, have something that publishes snapshots of the complete final state for these use cases.
Oh, you talked about that. So a snapshot, precisely what is?
Oh, it's that. Imagine that you are interested in the final state of a given entity published by some service. What you will want is to subscribe to something, not a domain event, but an event maybe, which the final photo each time it changes. And this is easy to do. This is event sourcing. Easy. It's nothing special. We want to do something special to be able to have this done in a generic way, so producers can just publish get by this something. And then something happens that takes the snapshots and publish the snapshots.
And the snapshot is
the photo, the final state. Sorry.
Okay, thank you very much.
The complete booking, for instance, in this case.
Really, thank you.
Hello. Actually, I didn't get this. You mentioned something problem that when we are using microservices, we may have multiple data sources for each microservice. For example, it has its own database, and the big challenge that you mentioned also is when we want to analyze the data. I didn't get what was the exact solution to overcome this. When we saved our data are persisted separately on each microservices databases, and how was the solution? I didn't get exactly. You want to when at the end of year, for example, an accounting report wants to execute. How was the solution in practice for this overcome? We still have separated data,
yes,
but actually I cannot connect this the solution and the problem from the.
You're talking about
maybe I didn't get it.
The exchange of data between the microservices, not the analytical part.
Huh?
You're talking about the exchange of data between the microservices.
Yes, the data are persisted separately in multiple databases, maybe.
Yes.
What was the solutions exactly to overcome this issue? You want to store somewhere as some conclusion
No, well, the solution is
or some
basically,
aggregated one?
if you want data from many microservices, you have two ways. You can query all of them. They have an endpoint, and they allow you to query, ask for data.
But was there something mentioned that with this, the approaches that you mentioned, something like domain events that, for example, I'm another microservice, but might be interested in some other events that are not related exactly to my data?
One way is querying, and the other is with domain events. If all the services that have data you want publish domain events with that data, then you can subscribe in Kafka to those domain events. You can subscribe to those topics, and then you will get the domain events. And then it's for you to store them, if you need, in memory or in disk, depends on your case, and join them together.
And if you want to say specifically which problem is fixing this Google data, big data, something that you mentioned, the tool?
Data catalog.
Data catalog.
For the analytical world, if you want to know how many events do I have? Do I have this data in a domain event or not? It's a UI where you can put booking, or you can put search, or you can put whatever, and it will tell you the events that you have with the documentation of the developers.
Okay, so that means that we still have separated databases, and
yeah, of course.
We don't need any aggregation.
You have to have them, yes.
Okay, thanks so much.
That's what creates the problem, actually.
Okay, thanks so much.
Okay, I think that we're kicked out. No? Yes? So we're done. Thank you very much.